Okay, hi everyone. So in this little video we're going to look at solving trig equations. So we have sort of started this last week, but it is kind of a tricky thing and I wanted to go over it again just to help you along and give you a bit more practice. So that's what we're going to look at this week. So let's start with some fairly sort of simplish ones. You've got 3 here, so if sine theta is a half, we have to find out what theta is. Now, you probably know you could just type in inverse sine of a half on your calculator. But let's going back to the video we did before. Remember, maybe we don't have a calculator and this question comes up, maybe it's a non-calculator paper. But we remember from the special triangles we just did that sine 30 gives us a half. Sine 30 is a half. So just using our special triangle knowledge, we can sort of write theta equals 30. Okay, now that is not the end, because you got this thing here which says you need to find all thetas within this range that give you a half. So I'm going to show you 2 ways of thinking about this. The first is the one that we introduced last week with the unit circle. So it's kind of like this. Remember we said that if you've got a unit circle and a triangle, if that's 30 there, then one of the key things that you learned last week is this distance is actually theta, but in this case 30. So we know that that's a half, so that length, that side of the triangle, is actually a half. So the question is, what other triangle would give us the same length? Now if you think about it a little bit, you can see it's the one on the other side here, sort of symmetrical, where you've also got 30 there, and that length is also the same. It's the same height, so it's a half. So the question is, what angle is that? Now remember, the angle is always measured from the start, so we're looking for this angle here. So you should be able to see that all you have to do is do 180 minus 30, and you get 150. So sine of 150 would give you the same height, so it would give you the same answer. So you could say that theta is 30 or 150. So if I were you, I'd just type in sine of 150 on your calculator to check that that's actually right. Now here's the second method, which I actually prefer for thinking about this, and you might prefer to use this. Now remember from last time, we figured out the graphs of sine, cos and tan, and this is the sine, whoops, that's not minus 2, it's minus 1, this is the graph of sine. You've got 180 in the middle, you've got 360, and you really want to get really good drawing these, sketching them up really quickly like that. That's all you need to do, just be confident sketching it. So our equation said sine of something gives us a half, and we're trying to find out what that is. So here's a half, it's halfway between 0 and 1, and actually you can see that whatever this is here, this angle, it will give us a half. Turns out it's 30, we knew that already. So this distance here is actually from 0 is 30. And then actually this angle, whatever that is, will also give us a y value of a half. And to figure out what that is, you just have to consider that this shape is symmetrical, with 90 being the sort of axis of symmetry. So you could say that that distance must also be 30, and therefore 180 minus 30, 150, would also give us a half. So this must be 150. So that agrees with what we came to when we did the circle. But I just prefer that. I just think it kind of gives you a bit of a deeper understanding of what's really going on. So those are the 2 values of theta that give us a half when we plug them into sine. So let's do it with cos. Cos of theta is root 2 over 2. using our special triangle, root 2 over 2 comes from cos 45. So we know that the first value must be 45. So now we have to find a second value. Okay, I'm going to do it both ways. So here's the circle. You choose which one you prefer. So now we said that we know if you've got an angle of 45, remember cos is 45. Cos is actually this value, this length here. Cos of 45, and we know that's, what did we say? Root 2 over 2. Root 2 over 2. Don't know what that is. Get rid of that. Okay. Yeah. So the question is, how else could we get root 2 over 2? Well, the other way to get it would be to have the triangle here and to have this angle here. And if you think about it a bit, you can see that all you have to do is do 360 minus 45 to find out the big angle, because that's 45 in there. So 360 minus 45 would be 315, I think. Okay, so that's the first way of doing it. I prefer to look at the graph, so let's do that. I'm gonna draw a quick cos graph. So this is a bit more intuitive because it gives you a bit of a deeper understanding of what graphs look like at the same time. Sketch yourself up a quick cos graph. And the thing that we found, wasn't it? It was 45, root 2 over 2, and it was 45, so it was actually here, 45 degrees, and root 2 over 2. And then you can say, well, what else would give us that same value? You can draw a line all the way across. Well, whatever that is, would also give us root 2 over 2. And by using the symmetry, well, that's 45 there. Well, that must also be 45 there. You just do 360 minus 45, and that's 315. So that's how to find the second solution using the graph. Or if you just remember that you take it away from 360, that's fine. But hopefully this gives you an understanding. So let's do the third one. Tan theta is root 3 over 3. Yes, let's look back at our special triangles. Root 3 over 3 actually comes out, that's tan 60. Tan 60. So theta must be, theta is actually 60. Now, I'm not going to do it with the circle, I'm just going to go straight to the graph because it's confusing with tan on the circle. So I'm going to draw a tan graph. So get good at drawing these graphs. I'm just going to show you how I do tan graphs. You got 360, 180, 90, so you put your axes in, 270. And what you do is you go up and then back to 0. And then you just repeat that. You just do the same thing again. And here you've got asymptotes. So that's a tan graph. Not a very good one, but it'll do. So what did the question say? Oh yeah, 60. Theta is 60. So that means theta is about here, isn't it? And it gives us this value, which I think was root 3 over 3. And that also crops up here. Now, using the fact that tan repeats after 180, all we have to do is add on 180 to our answer, because this distance is the same as this distance, it's just 180 degrees further on. So we just have to do 60 plus 180. So 180 plus 60 is 240. So there you go, that's how you solve basic trig equations and find, the two solutions. I'm just going to give you the quick version now. For cos, you can just take away from 360. For tan, you can just add 180 to get your next solution. And for sine, what did we do for sine? Sine's a bit more weird, but usually you can just take away from 180. But I'll show you some more subtle versions of that. Sine can be a bit tricky. Watch out for sine, but yeah, basically that's what you have to do. So there's the most basic version of the trig equations, and in the next video I'm going to show you some more tricky ones, and we're going to start using radians. Okay, thanks guys.